Hello everyone, I am Pranav Jain, and in the last videos we implemented queues using arrays and using linked lists, and in this video we will be implementing circular queues. What are circular queues? Let me explain it to you. So let's suppose we have this array 1, 2, 3 and 4. Okay, so this array, when we see in the memory, it's contiguous array. One after another we have elements, right? But in circular array, what we will say, after 4 we will go back to 1, and then 2, then 3, then 4, right? We have a circle here. 1, after 1 we have 2, after 2 we have 3, after 3 we have 4, and then after 4 we want 1. So this will make a array circular, and when we implement queue using arrays, it will make a queue circular, right? So this is what we have to implement. Whenever we reach at this position, we have to check if we have any element in this position or we have deleted it. What I mean by this statement is, in queues we have two pointers, right? One is front and other is rear. So if front is pointing to 1 and my rear is 4, that means a queue is full, right? But if here also we are considering the size of the array as 4, so if my front is pointing to 1 and my rear is 4, then my queue is full. But what if we have deleted this first element and second element, and a front is pointing to 3 and rear is pointing to 4, and then we have to insert at first position because this is circular queue, right? So after 4 we have an empty position 1, so we have to insert in this. How can we do that? We have to just link this 4 to 1. I mean, after 4 we should know we have to go and check to this 0th position. So we will simply say rear equals to rear plus 1 modulo means the remainder, we would say n is the length of the array. So here the rear would be 0, 1, 2, 3. Rear would be 3, 3 plus 1 is 4, and the size of array is 4. 4 modulo n is 0. 4 divided by 4, we get remainder 0. We go to the 0th position. And if it is anything less than 4 rear, well, let's for example it is 1, it's on this second position, then 1 plus 1 2 modulo n, which is 4. It will give the remainder as 2. So we will get rear as the next element, which is we simply increment rear by 1. So using this we can simply insert or delete. Similarly, for deleting, if we want to delete, we will write front plus 1 modulo n. If we are deleting and we get a position where rear is here and front is at 3, or let's say rear is at 2 and front is at 4, and now we want to delete more, we know there are elements here, right? So what we'll do, front equals to front plus 1 modulo n, will reach at position 0. So that's how deletion from the circular queue will be done, right? So let's implement this. We have already implemented queues using arrays, so we will be using the same. And do our modifications in this. So we have taken the array of size 5 and we have front and rear as -1. Let's see. Okay, so we always implement if you guys have been following the videos, we implement 5 methods, which is insertion, deletion, check if it is empty or not, peek, and simply display. Okay, so if is empty would remain same. If my front is -1 and rear is -1, that means my queue is empty. And if I want to peek, I'll simply say return array of front. Now I'm in this case I'm not handling the case when our queue is empty. It will simply throw the error. Okay, and now let's implement our enqueue method, right? So in our enqueue method, if my queue is empty, then the things will remain same. I'll say front plus plus, rear plus plus, array. I'll say simply insert the element and I'll return. And then we check the full condition if my queue is full or not. Here we have checked if rear is equal to length of the array, but we would have to add more. Our queue would be considered, circular queue would be considered full if my rear would be equal to front -1, right? If my front is 3 and rear is 2, then I cannot insert more elements, right? That means my queue is full. And this condition cannot go alone. With this we would have to say if our rear is at the end of the list and our front is at the beginning, then only we can say the queue is full. So we will say front equals to 0 and rear equals to length, then our queue is full. So we have added our full conditions here. Now what we would say not just plus plus rear, we would add this condition here, right? We would say rear equals to rear plus 1 modulo size of the array, which is dot length. One second, yes, error dot length, and we can simply say array of rear equals to element. Okay, so with this our insertion operation is done. Now moving to the deletion. So we delete from the beginning of the queue, from the front. So we check if it is empty, then we say empty queue. If my front is equals to rear, that means this is the only element in the list. So we'll say after deleting this element our list will be empty. We'll say front equals to -1, rear equals to -1, and then we'll return. And after that, if both these conditions are not there, we'll simply say front equals to front plus 1 modulo size of the size of the array, right? So we write this as error dot length. This will complete our deletion operation. Now how will we implement our print operation? So if it is empty, we will simply say empty queue. Also, if our now we would have to consider two scenarios here. If my front is before rear, then I will simply print from front up till rear. But if my rear is at 2 and front is after rear, for example, then I would have to print from front up till the length of the array and from 0 up till the rear. So considering these two scenarios, we can update our print method as if rear is greater than or equal to front. If that's the case, we simply print from front to rear. But if that's not the case, if my rear is less than front, then first I will print the loop from front up till the length of the array, and then when this is done, I will print from 0 to front, 0 to rear. Sorry about that. Zero to, this would be also equal to, because it starts from 0. Right, a little formatting. Okay, so this is a print method. Now we have successfully implemented our insertion method, deletion method, check is empty method, peek method, and print method for circular queues. Now let's test a circular queue. We are inserting 3 elements, then we are printing, then we are deleting one element, which means deleting from the front, then we are simply printing the elements and then deleting 2 more elements, making the queue empty, and then checking if it is empty or not. Let's see if this test case runs successfully. Okay, we inserted 3 elements, we printed that, we deleted, then we printed, then we peek, okay, so there is one problem, we haven't changed the implementation here. It's circular queue, not queue implementation. In queue implementation we peek the rear. Okay, now it should give us the right result. Yes, so we have 3 elements printed, deleted, and then we peeked, and then we checked. Right, now after deleting, if we insert again and again we print, let's see what happens. Right, so now if after deletion also, where we have the case when only 3 is there, and then we insert again, and also if I change the size of the array to 3, okay, then it should insert in the beginning. Right, so let's check. It will insert in the beginning, but it will print in the way that it will come after 3, because we have implemented a queue in this way. This way only, this will print first from front up till the length, and then from 0 to rear. So first it will print 3, and then it will print the elements that we will insert. Okay, so let me insert 4, 5. Inserting 6 should give us the error, the print statement that our queue is full, right? First we add a print here. Now let's see. So it was the initial array. Right. Let me also remove this from here. Initially our array was 1 2 3, then we got 2 3, then we peak and we got 2, and then we removed one more element which is 2, and we remained with 3. Then we inserted 4 and 5. We tried to insert, we printed it, then we tried to insert 6, and then we dequeue, and when we check if our queue is empty, it is returning true, which is wrong. What happens when we insert 6? Okay, so we have put AND here, which is the wrong condition. We should be adding here OR. Okay, so now it should give us the right output. Either this condition or this condition. Both cannot happen at the same time. Okay. Yes. So now we are getting the right output. 1 2 3 2 3 2 3 4 5. On inserting 6, queue is already full, and then we delete 1, we get 4 5, and we check if it is empty, and it returns false. So we have successfully implemented queues, circular queues using arrays. That's it for this video. See you in the next.